We are now on day 5 of the solving section. And today's goal is, well, the second half of the day is to continue practicing the quadratic formula that we did yesterday. But the first half is not to find what x equals, but to know how many solutions exist without actually solving. So there's a couple different ways that we can do that. So topic for today is how many solutions exist. And there's 3 different ways to answer that question. First strategy, you can look at the graph. If you have a graph, or you have a graphing calculator, or make the graph by hand, you can visually see how many times it crosses the x-axis to know how many solutions there are. So graphically, if it crosses it twice, that would be 2 real solutions. And this is similar to what we did when we did the absolute value function section back in Unit 1. If it crosses it never, something like that, it would have no real solutions, but it does still have 2 imaginary. So if you would solve for x, your answers would be imaginary. And then the last scenario is when the vertex stays on the x-axis, so there's no shifting vertically up or down, and that is when there is 1 real solution, however, it's repeated. So even though it's 1 number, that number counts twice, so it's still 2 solutions. Quadratics should always have 2 solutions, either 2 different, 2 imaginary, or 2 of the same. And that's because the quadratic has an exponent of 2, a degree of 2. It'll always have 2. Again, 2 different, 2 imaginary, or 2 that are the same, repeated. The second way, we talked a little bit about during the first section of this unit, which is to compare the A and the Y of the vertex. Remember, the Y of the vertex controls the shift up or down, like the K value. And you can compare their signs. So if they're the same sign, then there was no real solution, also now known as 2 imaginary. We didn't know about imaginary back then. If they have different signs, then there's going to be 2 real solutions, 2 distinct ones. And if the y of the vertex is 0, which with the absolute value we called the k value was 0, because k was the y of the vertex, that is when there is going to be 1 real, but that 1 real solution is again a repeated solution. These first 2 strategies are review. We've already talked about these this year in terms of knowing how many solutions exist, looking at the graph and comparing the A with the Y of the vertex, because A controls whether it opens up or down, and Y the vertex controls whether it shifts up or down. So that combination will affect how many times it crosses the x-axis. The third and final way is the new way that you guys are going to practice on tonight's homework, and that's called the discriminant. It's part of the quadratic formula, and it's the part underneath the radical, the b squared minus 4ac. By calculating this discriminant, it will be a predictor as to how many solutions there are, and again, not what they are, just how many. So there's 3 scenarios with this. If the discriminant comes out to be a positive number, that's going to be 2 real solutions. Reason being, if you get a positive discriminant, think about the discriminant as part of the whole big formula. It's under the radical, and positive numbers under the radical will give you 2 answers because you have the plus or minus in front of it. If the discriminant is negative, we're going to have the 2 imaginary, or no real solution. And that's because if you have a negative underneath the radical in the formula, the negative comes out as I. so our answers are imaginary. And the last case is if the discriminant is equal to 0, that's going to produce only one real solution, which will count twice. And that's because if you think of the quadratic formula, how it's the plus or minus the square root, if you have the square root of 0, plus 0 and minus 0 give you the same thing. A positive 0 and a negative 0 are not different, so you won't get two different solutions. You will only get one. So we're just going to try one of these discriminant examples, and the rest will be practice on homework. So I want to know how many solutions exist. And we're going to use the discriminant method. So if I gave you x squared minus 6x plus 9 equals 0, does need to be equal to 0, just like when we did the quadratic formula yesterday. And I'm going to sub the numbers not into the whole formula, but just the b squared minus 4ac. Please still keep the b in parentheses because of the negative. So b squared minus 4 times a times c. Carefully simplify this down. When you square the negative 36, it should become positive. Only one negative with the 4ac, so it stays subtraction. And 4 times 1 times 9 is 36, so our discriminant is 0. Now that does not mean there's no solution, which is a common misconception. If we look back to the notes we just took, if the discriminant becomes 0, that actually means one real solution, not no solution. So you got to be careful. The discriminant is 0, so the solution is 1. If you did the formula and you got 27, okay, so 27 would tell you that's positive. That means there'd be two real solutions. 27 is not the solution. It's just telling you how many exist. And if you did the formula and got like negative 8, that would mean that there's two imaginary solutions because it's negative. So that's the discriminant. I did mention in one of the prior videos that when you do the discriminant, if you get a perfect square value, that means the original problem was factorable. And 0 would count as a perfect square, so that would tell you that x squared minus 6x plus 9 is a factorable expression. So if you got 4, 9, 1, 16, 25, any of those perfect squares, you would have been able to factor. And if you get numbers that aren't perfect squares or negatives, it's not a factorable problem. So you definitely wouldn't try to solve it by factoring. The remainder of class today, you're going to do quadratic formula practice, and your homework is to finish the practice along with a riddle worksheet that has this idea of the discriminant on it. That is it for today. Tomorrow you guys will have a quadratic formula quiz and start the real world.